Alright, in this video we're going to cover the study guide for DMA 60. If you've worked through the whole study guide, scroll to the problems that you want to check. I plan on covering every problem in this video. So number one, we want to multiply these two things together. And we're just multiplying. There's no addition or subtraction. And remember your rule. When you multiply like bases, for example, there's a base of x, there's a base of x, you want to add the exponents. Therefore, we have x to the 8th. And the same thing with the y's. What the y's have, well, that's a like base. That's a like base. So we add the 2 and the 3, we get y to the 5th. The rule to remember, when you multiply like bases, you want to add the exponents. Now there is a rule over here for number 2 as well. All this stuff right here, we think of it as one big piece, one big term, and I want to squeeze in some ones. I did that in class too. That 4 is to the first power. That x is to the first power. So we have all these powers in here raised to another power. The rule for that is to multiply the exponents. So therefore we have 4 to the first becomes 4 squared because we take the 1 right there times 2. The same thing here, 1 times 2, that gives us x squared. Y to the 6, because we take 3 times 2. And the same thing for this w squared, 2 times 2, we get w to the 4th. Now let's go one more step, because 4 squared is going to give us 16, but that's the only thing I want to change, or everything else remains the same in our answer. Now you can take that approach, or you can take a slightly different approach. Since this thing is squared, you could think about this rule back here. If you understand that, then just fast forward through this part, but I at least want to mention it. So 4x y cubed w squared all squared is the same thing as saying 4x y cubed w squared times 4x y cubed w squared. That's what happens when you square something. You just take all that stuff and multiply it times itself again. So now notice, if we take 4 times 4, that gives us the 16. Adding these exponents, that's x to the first and x to the first. We add those exponents now. Look, there's the x squared. Y cubed, there's y to the 6 when we add the 3 and the 3. And w squared, that gives us w to the 4th when we add the 2 and the 2. So we were kind of going back and using this rule when we did it like this. Whereas if you just deal with it right here, you have powers raised to another power, so we can multiply the exponents there. Now for this next example though, number 3, I would definitely recommend just sticking with it like this. Instead of writing this thing out 3 times. Here I wrote this one out twice. I would not recommend doing that. I would just recommend using the rule powers raised to powers, you multiply your exponents. So that 3 is understood to be to the first power, the x has an exponent, the y has an exponent, and that 4 is understood to be to the first power. All this stuff is one big piece, one big term. So when we have all these powers in this one term raised to another power, we can multiply the exponents again. So therefore we have 3 to the 3rd, x to the 9th, 3 times 3 is 9, and 3 times 2 is 6, so we have y to the 6th over 4 to the 3rd power. And let's go one step further and cube the 3 and cube the 4. 3 cubed is not 9. 3 cubed, 3 times 3 times 3 is 27. X to the 9th, y to the 6th, over 4 cubed is not 12. 4 cubed is 4 times 4 times 4. That gives you 64. And looking here, 64. If we try to simplify 27 over 64, we cannot do that. So we will leave that answer just like it is. That's totally simplified. Now I want to make some more room here for these last two. All right, number 4. Again, we have some of that same stuff going on that we had right here. All of that stuff is one big piece. So we have all these powers raised to a power, and now we're going to bring in a few more things too. But since all of that stuff is one big piece, one big term, we can multiply all the exponents by 3. Just don't forget that that 4 is raised to the first power. That way now we can go and multiply all these exponents. So when we do this, up top, that's going to be a to the 9th, b to the negative 6. We'll deal with the negative exponent in a minute. For right now, I'm just going to multiply them all out. And now I'm going to come and do the same thing down here. We're going to multiply the 3 times 1, the 3 times 2, and the 3 times the negative 3. So this is all over 4 cubed, a to the 6th, and b to the negative 9 when we multiply those exponents. Now it's up to you how you want to deal with it from here. Well, first things first, I am going to notice, however, the 4 cubed, we can say 64, 4 times 4 times 4. And I'm going to do a couple of other things right now. Some of you may remember that when you have negative exponents, if this was at the top, and it is at the top, we want to shoot it down. And since this has a negative exponent at the bottom, we want to shoot it up. That's one way we approach these problems. So I'm going to do that right now. We have a to the 9th. Move this up to the top to make it b to the positive 9 over, let's not confuse these 9s with a's. They kind of like a's to me. So a to the 9th, b to the 9th when we shot that one up. Down here at the bottom, 4 cubed is 64. We can leave it down there. It does not have a negative exponent. The a to the 6, we'll leave it down here for right now. And this b to the negative 6 up top, we're going to shoot it down so it becomes b to the positive 6. Now from here, what I ask myself is, okay, we're going to have to subtract some exponents because we have like bases at the top and bottom. And back when we multiplied the like bases, we added the exponents. When you divide like bases, you subtract the exponents. So when we divide these like bases, we're going to subtract them. Since we have 9 of these a's up top and 6 of them at the bottom, when you subtract, you're going to be left with 3 of them at the top. So we have a cubed. The same thing for the b's too, because we have more up top than we do at the bottom. 9 minus 6 gives us 3, so we have b cubed up top. At the bottom, all we have left is a 64, because essentially what we're doing when we subtracted here, that's getting rid of, those a's and b's at the bottom since we had more of them at the top. So a cubed, b cubed over 64 is going to be the answer to that problem. And one more in this little section. All that stuff right there is one big term. It's raised to a power. So therefore, the 4 has a 1. The b also has a 1 as an exponent. Let's multiply these exponents together since we have some powers raised to a power. Therefore, we have 4 to the negative 3, a to the negative 6, b to the negative 3. I just multiply those exponents. This one over here, there is no power that this is raised to, so we're just going to bring this along for the ride and multiply by it. So we have 2, a to the 5th, b squared. And now it's up to you how you want to deal with this from here. What I'm going to do, since we're multiplying all this stuff together, 4 to the negative 3. First of all, 4 to the negative 3 is actually 1 over 64. Because what we're really doing is we're making this become, oh, what the heck, I'll come over here and show you. 4 to the negative 3, that becomes 1 over 4 cubed. Notice the exponent becomes positive. So then 4 cubed is 64, but we have the 1 up top. And we talked about that in class. I remember, I think it was worksheet number 1. We talked about the negative exponents there. Now for these right here, however, I'm going to go ahead and combine these bases by adding the exponents. Because we're multiplying this and we're multiplying this. These are like bases, so therefore we add our exponents. That gives us a to the negative 1. Negative 6 plus 5 is a to the negative 1. We'll deal with the negative exponent in a moment. Same thing with this b. b negative 3, b to the 2nd. These are like bases, so we add the exponents when we multiply these like bases. Therefore, we have b to the negative 1. So it turns out that we actually end up shooting that stuff to the bottom as well, because we want a positive exponent down there, so we're going to shoot it down there with the 64. And we do the same thing with the b. Therefore, the only thing you have left up top is that 1, and you need to show something up there. Do not put 0. So we still have a 1 up top, however, everything else gets moved to the bottom. The 64, that was from what I mentioned back here, and now we have an A and a B. And what you can do is you don't have to put the 1s there, because that's understood to be A to the positive 1, B to the positive 1, since we did shoot these down to the bottom. So that's our answer for number 5. On to the next problems. Number 6, identify 2x cubed plus 8x minus 12 as a monomial, binomial, or trinomial. Find the degree of each term and the degree of the polynomial. Well, first of all, is it a monomial, binomial, or trinomial? We can't combine anything in here, and don't be thinking about factoring right now, but this is a trinomial because it's 3 terms. The 2x cubed is a term. Let me write those down. 2x cubed is a term, 8x is a term, and the negative 12 is a term. So let's find the degree of each term. The degree of this term is equal to 3. The degree of this term here is 1. Notice I'm using the exponents of each term. And the degree here. Negative 12 is a constant. I've mentioned this in class, but we can think of x to the 0 power being there, because x to the 0 power is 1 automatically, so we really just have negative 12 times 1, which is negative 12. But anyway, with the x to the 0, what's that exponent? That degree is 0. That's a rule you can remind yourself. Any constant in a polynomial, its degree is going to be 0. Now, we answered that question right then. We found the degree of each term. However, let's find the degree of the entire polynomial. The degree of the entire polynomial is going to be the biggest degree you have out of all these degrees. So therefore, the degree of the entire polynomial is going to be 3, because 3 is the biggest one we have here. All right. Number 7, add or subtract the polynomials. Here we're just adding. That plus does not change anything, so really what you can think about, there's no sign out here. Those parentheses really aren't that important. And same thing over here. That plus is not going to change anything, so these parentheses aren't important. We don't have to change any signs. And now we can just combine like terms. We had the 15h cubed and plus 3h cubed. That gives us 18h cubed. Remember, when you combine like terms, do not add those exponents. We're not multiplying these things together. We are just combining like terms. 15 plus 3 is 18. We don't change the h cubed. We leave that alone. Keep on going. So minus 7h squared. Be careful with your signs. Minus 4h squared. Same thing here. We just combine like terms. That's going to be minus 11. We do not change our exponent. Minus 7 minus 4 is minus 11. We leave the h squared alone. And then we have these constant terms that I've mentioned back up here too. Positive 12 and a positive 10. 10 plus 12, 12 plus 10. No matter how you look at that, you're going to get plus 22. So there is the answer to that problem. We just added those together. 7b, tricky, tricky. Before we do this one, suppose I ask you to find or do this problem. Subtract 5 from 20. Subtract 5 from 20. You do not say 5 minus 20. What you really do is you do 20 minus 5. That answer is 15. The point I'm trying to make is if you're not careful when you read this, you might just take 5 minus 20. But we're taking 5 from 20, therefore we take 20, subtract 5, we get 15. We want to keep that in mind when we do this. This stuff right here is in the same spot that 5 is in, whereas this stuff right here is the same spot, is in the same spot that the 20 is in. So this is the first thing you want to write, just like we wrote 20 first. So we have 2b cubed minus 5bc. That's the first polynomial. And we want to subtract that junk from that, just like we subtracted 5 from 20. So this is the second polynomial that we're going to write down, and we want to subtract it. But I'm going to be careful. Remember, we have to use parentheses here because we're subtracting that whole polynomial. I don't know why I put the parentheses right there. I need to keep on going with it. So 6bc plus 11. Make sure I wrote everything down right. 2b cubed minus 5bc. 3b cubed c, 6bc plus 11. All right, we're subtracting that whole thing. Subtracting that from that. Now, in this next step, those parentheses there are not important because there's nothing out in front of it to change those signs. So therefore, we have 2b cubed minus 5bc. However, this minus is going to change all these signs. And you have to be careful with that. So therefore, right here, we have minus 3b cubed c plus 6bc minus 11. I'm distributing that understood -1. I'm just multiplying -1 times everything, really. And all that's doing is just changing the signs. And now from here, we combine like terms. I don't see any more b cubes by themselves. Be careful, that is not a like term with that. That has a c in it, this doesn't. So therefore, 2b cubed is going to be by itself as a term. Let's see. I don't see another b cubed c either, so I'm going to go ahead and bring that down. So minus 3b cubed c. We're done with those two, but those are not like terms. So maybe, let's see here. I'll write those in different colors for right now. All right, what else do we have? All right, now we have some like terms. Minus 5bc plus 6bc. They both have a bc in those terms. Minus 5 plus 6 is a positive 1, so we'll just say plus bc. I'm okay if you want to write a 1bc in there, but I'm going to leave that understood 1 off. And then the other piece, minus 11. There are no more constant terms up here, so that's our final answer to that problem. Forgot what number that was, but anyway, okay, that should have been number 7, I guess. It was. So in number 8, we want to find a polynomial that represents the perimeter of the rectangle. Perimeter is the distance around the shape. So we don't want to multiply this trinomial times this binomial. Actually, the way I talked about it in class is if you have 5a squared plus 2a minus 8 inches down there, we also have that same measurement across the top up here. And the same thing happens for this a minus 4 inches. Therefore, we have a minus 4 inches over here. So to find the perimeter, you want to add up all 4 sides. Now, if you were to write all this stuff down, it can get long. So the perimeter is equal to, well, we had the a minus 4, so we got a minus 4 plus a minus 4. That is the 2 widths, if you will, the widths of the rectangle. And then we have our 2 lengths, so we want to add those together as well. So we have 5a squared plus 2a minus 8, and then plus 5a squared plus 2a minus 8. Now some of you might prefer to use the perimeter equals 2 times the length plus 2 times the width. That's fine, you're going to get the same answer. But from here we want to combine like terms. None of these parentheses are important because there's no signs that are going to change it. There's no negatives or anything to distribute. So those parentheses aren't really that important. I was just putting them there to show you a minus 4, a minus 4. We're adding those two up. And then the 5a squared plus 2a, that comes from the 2 lengths that we have right there. So all you really want to do here is hunt around for like terms. I'm going to start with the a squares since I prefer to write these in order. 5a squared, that gives us 10a squared. Look at all your a's now. 2a, that's 4a, plus another a, 5a, plus another a, that's 6a. So we have plus 6a. And then look at all these constants that you have. Minus 8, that's minus 16. Minus 4 more is minus 20. Minus 4 more is minus 24. There is the perimeter. And let's not forget the dimension. The perimeter is 10a squared plus 6a minus 24 inches. So all we're really doing there is using an application of adding polynomials. And you can almost eyeball this now if you think about it. If you look at all the a squares that you have around this rectangle, there's an a squared, there's an a squared. 5a squared, 5a squared is 10a squared. Look at all the a's that you have around the edge of this rectangle. 2a, 3a, 4a, 5a, 6a. Look, there's our 6a right there. And look at all your constants. Minus 8, minus 4, that's minus 12 if you combine those. So minus 8, minus 4 is minus 12. Minus 8 more is minus 20. And then minus 4 more is negative 24. There it is right there in our answer. So that's how we find the perimeter of that rectangle. All right, for number 9, the cost C for an ice cream company to produce X pints of premium chocolate ice cream is given by the formula C equals 3.25x plus 600. I'll explain that formula in a second. If the company sells each pint for $4.25, the revenue R from their sale is given by the formula R equals 4.25x. Now, before we read these questions any further, here's what these two formulas mean. 3.25x plus 600 is how much it's going to cost the company to produce it. So they're going to have to spend that money to produce the ice cream. What does this formula mean? For every pint X, notice it says X pints. For example, if they were to do 10 pints of ice cream. Let's not even answer these questions yet. I want to explain what these formulas mean in regards to the problem. So if they produce 10 pints of ice cream, what this formula is going to tell us is how much it's going to cost them to produce 10 pints of ice cream. So 3.25 times 10, we're letting X be 10 pints plus 600. Now y'all, a pint of ice cream, Ben & Jerry's, that pint, that's a pint of ice cream. Most they come in smaller sizes, but I'm sure you have seen in the grocery store a pint of ice cream. That's a ridiculous cost. It's going to cost them $632.50 just to make 10 pints. That's ridiculous. There's no way they can make a profit off of that, because what are they going to do with those 10 pints of ice cream? They're going to go back and sell them for $4.25. So let's see how much money they're going to make, or how much money they're going to bring in. $4.25 times those 10 pints, they're only going to bring back in $42.50. They are not making a profit because their cost is more than their revenue. Cost is how much they got to spend. Revenue is how much they're going to sell it for. So, thinking about those two formulas with what I just said, I mean, 10 pints, we got to make a lot more than that to make some profit. How do you find your profit? Well, that's what question A is asking you to do. Question A says, write a formula that finds the profit P by subtracting the cost. We want to subtract this from the revenue. Well, we did a problem earlier in this video where we subtracted something from something else. And if you recall, look back at the video. Where is it at? Oh, it was right there. We subtracted blah from blah. What we ended up doing was we took the second piece and we subtracted the first piece by the way it's worded. And that's exactly what we want to do in this problem here. We want to subtract the cost from the revenue. So therefore, for question A, we take the revenue minus the cost. That's going to be equal to our profit P. Our revenue is 4.25x. Subtract the cost. Now let's be careful here. Since we have two terms, I'm going to write it in parentheses just to remind myself that what we're going to have to end up doing is distributing that negative. So from here we have 4.25x minus 3.25x and minus 600. That's going to be equal to our profit. All I did there was distribute that negative to that term and to that term right there. Let's combine like terms. 4.25, $4.25 x minus $3.25 x. That gives us just plain old 1x, or x minus 600 is equal to P. There's our profit function. All right. Now, what did X represent? X represented the number of pints. If you go back up here to the top, X is how many pints they're going to make, and they're going to turn back around and sell them. Well, it looks like right here, the only way they're going to be able to turn a profit, well, X minus 600. Think about that $10 or 10 pints I said a while ago. 10 pints minus 600, they're not going to turn a profit. It looks like by this formula, they're going to have to produce more than 600 pints to make a profit. For example, if they made 601 pints, they would make $1 profit. Let me show you that in this example, or the two formulas up here again, how I'm coming up with that number. This is the answer to question A, but I want to look a little bit deeper into it. So, suppose the company made just 600 pints. Suppose they made 600 pints. How much is that going to cost them? Well, the cost function is $3.25 times the number of pints plus 600. So 3.25 times 600 pints plus 600 additional dollars. It's going to cost them $2,550 just to make those 600 pints of ice cream. How much are they going to sell them for? They're going to sell them for $4.25. So therefore, if we take $4.25 times 600 pints, that's that same number. That's that same number. So it costs them $2,550 to make the 600 pints. When they turn around and sell those 600 pints, they're going to make their money back. And that number 600, if we take 600 minus 600, they're not making a profit. They're breaking even. That's their break-even point. And that's something you'll look at in other math classes as well. But now, suppose they were to sell 601, or make and sell 601 pints of ice cream. How much would it cost them to make 601 pints of ice cream? Let's find out. The cost is $3.25 times the number of pints they made plus the additional $600. I'm getting that from the cost function. So it's going to cost them $2,553.25 to produce 601 pints of ice cream. How much money are they going to bring in from the sale? Well, we produced 601 pints of ice cream. If we sell them at $4.25 a piece, we're going to bring back in $2,554.25. That number right there is $1 more than the price it cost us to make it. So their profit would be $1 off of making and selling 601 pints of ice cream. Look at that formula. 601 minus 600, that's going to be $1 profit. Now you might say, well, man, that's a lot of ice cream. Well, think about Ben & Jerry's. It's all over the world, or all over the country at least. I mean, they're selling millions, probably millions of pints of ice cream, or hundreds of thousands at least. So yeah, they're producing a big profit, because once they produce 601, 602, 603, 604 pints of ice cream, as that number gets really big, their profit is going to go up. For example, let's suppose that this company produced 10,000 pints of ice cream. And that's actually a small number compared to what Ben & Jerry's does, but I'm just trying to relate it to the real world. So suppose Ben & Jerry's, let's call, I'm talking about it so much. Ben & Jerry's, they produce 10,000 pints. $3.25 times 10,000 pints. It's going to cost a lot to make that, but watch the profit they turn over. So 10,000 pints, and then plus the additional $600 that it costs to make. So $33,100 is going to be the cost. Let me squeeze that over here. I know I'm going off on a tangent here, but hey, I do that sometimes. So the cost for 10,000 pints was $33,100. That's how much the company's spending to make 10,000 pints of ice cream. But now if they turn back around and sell those 10,000 pints for $4.25 a piece, that's what the revenue is. That's how much they're going to sell it for in the store. So times those 10,000 pints that they made, they're going to bring back in, their sales is going to be $42,500. So their revenue is $42,500. Well, now we're starting to turn a profit because this is how much they made on their sales. That's how much it costs to produce it. If we subtract those two numbers, that's going to be our profit. And we are going to turn over a profit because we're bringing more money back from our sales in the grocery store than what it cost us to make it. So take the 42,500, subtract the cost to make them, 33,100, and there is the profit of $9,400. Well, y'all, one more time, if we look at this profit function, look how 9,400 pops right out, because X is the number of pints of ice cream that we made. If we take 10,000 pints of ice cream, subtract 600, there's our profit, $9,400 again. So this formula that we found, it helps us find the profit much quicker versus going and plugging something into here and plugging something into here, and then we subtract the numbers. We've combined these two polynomials together to get a profit function. So now that I went on that wild tangent, question B, will the company make a profit if they sell 500 pints of ice cream? Explain why or why not. And the answer is going to be no. I just talked about this too. If we look at it two different ways, again, one more time, how much does it cost them to make 500 pints? Well, there's the cost function. So $3.25 times 500 pints of ice cream plus the additional $600. That's the cost function. So it's going to cost them $2,225 to make them. And then they will turn back around and sell those 500 pints of ice cream for $4.25 a piece. Remember, that's our revenue function. So times $500, or excuse me, 500 pints, they're only going to sell, and if they sell those 500 pints, they're only going to make $2,125. That number is smaller than what it cost them to produce. All right, and what's the difference between those numbers? It's actually going to be 100. The cost, if we plug in 500, 3.25 times 500 plus the 600, again, that answer was $2,225, whereas the revenue function is going to be 4.25 times 500. Therefore, the revenue, if we work that out, we're going to get $2,125. It's costing the company more to make it than what they're selling it for, because it's such a small amount if you're looking at like a mass production. So they're not going to make a profit. And if we look at it over here too, they're actually going to lose $100 because it cost $100 more to make it than what they sold it for. If you subtract that, revenue minus cost, that's what I said over here. 2,125, that's the revenue. Subtract the cost, 2,225. Put an extra 2 right there. That's negative $100. They're not making a profit if they only make 500 pints. Look at that same number pop over here. 500 pints minus 600. Hello, that's that same number right there. So they're not making a profit. They're actually losing money. And let's explain that. They are not making a profit because the cost of making 500 pints of ice cream is more than the revenue from selling 500 pints of ice cream. And I know I spent quite a bit of time on this problem, but I'm just trying to get you to look at it. These real world problems, that's where the math really comes to life, but we had to explain that. If the cost is more than the revenue, you're not making a profit. You obviously want your revenue, the money you sell the stuff for. You want that to be a bigger number. That when you take that revenue and subtract how much it cost you, then you will start turning a profit, should that be a positive number. All right, enough of that one. Let's go on to another problem. 10, 11, 12, 13, and 14, we're all going to be multiplying these polynomials. Since this is one term times three terms, we want to distribute. And just don't forget to multiply the coefficients. So 6 times 2 is 12, and we add the exponents since these bases are the same. So we're multiplying y to the 4th times y squared. That's going to be y to the 6th. And let's continue this. 6 times negative 3, that's minus 18. Adding the exponents, y to the 4th and y to the 1st is going to be y to the 5th. And then multiplying 6 times 4, we get 24. Y to the 4th power. There's no more y's, so we just leave the y to the 4th over there with the 24. And that's it for that one. All right, some of you might like to use the FOIL method here, or maybe repeated distributive property, however you want to tackle this. X times 2x, that's going to be 2x squared. Again, we're still adding those exponents because they both have 1s. Then x times 7, that's going to be plus 7x. Now let's come back and do the same thing with the negative 8. Negative 8 times 2x, that's minus 16x. And then negative 8 times 7, that's negative 56. Now let's combine like terms. There are no more x squares except for the 2x squared. However, we can combine these two middle pieces right here. 7 minus 16, that's going to be negative 9x, and then bring down your minus 56 since you don't have any more constants up here. And that is it for that problem. On to the next one. 6x minus 5y squared. This is not one term. You have two terms right here. So we can't do that thing that we did earlier in the video where we distributed the 2 to all the exponents. Hang it up. You can only do that if you have one term inside of the parentheses. So how do we tackle this one? We can write this as 6x minus 5y times 6x minus 5y. That's what it means to square something. You multiply the thing times itself. With it written like this, we're going to carry out our operation like what we did up here, because we have two terms times two terms. So doing that, 6x times 6x, that's going to be 36x squared. 6x times a negative 5y, that's going to be 6 times negative 5, that's negative 30. Then we have an x and a y, so we're going to put xy. Doing the same thing on the inside here. Negative 5y times 6x, negative 5 times 6 is negative 30. And then we have an x and a y again. I'm going to put them in alphabetical order. And then last but not least, negative 5y times negative 5y. Well, negative 5 times negative 5 is positive 25. A y and a y gives us y squared. And now let's finish this up just like what we did in number 11 where we combine like terms. We have no more x squares. Be careful, that is not an x squared. So here we have 36x squared. These do not cancel out. That's minus 30 and minus 30. They both have xy's. So minus 30 and minus 30 is minus 60xy. And then bring that down, plus 25y squared. That's it for that one. All right, 13 and 14. I'm going to make some room. All right, I don't know what those, ignore that black right above there. Same thing over there. All right, this one here, 2 terms times 2 terms, but you're going to notice something special about this one, 8x times 8x. Be careful there, that's going to be 64x squared. Don't forget to add those exponents. 8x times 3, that's going to be plus 24x. And now let's come back and repeat this process for that negative 3. Negative 3 times 8x is minus 24x. And then negative 3 times positive 3, that's negative 9. So we have to subtract 9. Combining like terms, 64x squared, there's no more x squareds. Now these two right here do cancel out. Positive 24x minus 24x, they cancel out, so bring down your minus 9, and that's all we have for that one. You might be wanting to look back up here at the last problem that we did, number 12. These two had the same sign, so we added those two numbers together and kept that sign, whereas these were opposites. So, be careful there. Those two can get confusing, or people get those two things mixed up, but as long as you're looking at your signs and being careful with that, you should be okay. And then this last one right here, a binomial times a trinomial. That means we're going to have to take this 3x and multiply it times x squared, multiply it times the negative 4x, just watch your signs, and then multiply it by the positive 2. Doing all that, 3x times x squared is 3x cubed. Adding the exponents there again. 3x times a negative 4x. That's going to be negative 12x squared. Watch those signs and remember to add those exponents. And then 3x times 2 is plus 6x. Let's come back and repeat that process for the negative 2. Negative 2 times x squared is minus 2x squared. Negative 2 times negative 4x is positive 8x. Watch your signs. And then negative 2 times 2 is negative 4. And now let's make sure we combine like terms correctly. There are no more x cubed, so we have 3x cubed. The x squares, minus 12x squared minus 2 more x squares, that's going to be minus 14x squared. Looking at our x's, positive 6x and positive 8x, that's going to be positive 14x. And then we have no more constants up here, so we bring down the minus 4, and that's our final answer to that problem. Now, number 15, we want to find the area of the rectangle. A problem earlier in the video, we had to find the perimeter, and I said not to multiply the two sides together, but that is how you find the area of a rectangle. You take the length times the width. So we want to multiply these two things together. Therefore, we can say area is equal to 2x minus 3 times 4x minus 5. Taking the length times the width. It doesn't matter which one you write down first since you're multiplying two things together. And now we do the same thing we did back in problems 14 or those last ones on that last page. So 2x times 4x, that's going to give us 8x squared. 2x times negative 5, watch your signs there, that's minus 10x. Negative 3 times 4x is minus 12x. And then negative 3 times negative 5, that's positive 15. And don't forget to combine like terms in here. So therefore our area is equal to 8x squared. Watch your signs right here, that's minus 22x. And then plus 15. And let's not forget one thing here, the area is going to be this, and then it's centimeters squared or square centimeters. That's how you find the area of a rectangle. You take the length times the width. And just recall, we had a rectangle like this, and if it was 4 centimeters by 3 centimeters, that area is going to be 4 times 3. And we do say 12 centimeters squared. So that's why I put that centimeter squared on the end of it. This one looks a little bit crazier, obviously, because we're doing some algebra with this. Division. We're dividing by one term down here, 8ab. So the way we can tackle this is we can write each piece separate up top. We can put 8a cubed b over 8ab minus 32ab cubed over 8ab. Notice here that we do have two fractions, and if we wanted to combine these fractions back together, we could go right back to where we started since we have the common denominator. However, we don't want to do that. We don't want to go backwards. Let's divide these. The 8's cancel out in the first fraction. If this is a to the first, understood 1, a cubed over a, if you subtract your exponents, you have more a's at the top, so we have a squared. 3 minus 1, that's how I get that 2. The b's cancel out just like the 8's did. So all we have left in that first fraction is a squared. Bring down your minus. 32ab cubed over 8ab. 32 over 8. 32 divided by 8 is 4. The a's cancel out completely. And then, similar to the a's back over here, these b's, there's more b's at the top than there are at the bottom. When we subtract the exponents, we get b squared. 3 minus 1 gives us that 2. And that's our final answer for that problem. Number 17, we're still going to use division here. What binomial, when multiplied by 3x squared? What does all that mean? What binomial, when multiplied by 3x squared? I'm just going to write that down. 3x squared times some binomial, we don't know what it is, but we want it to give us yields, that means it equals 21x to the 9th minus 15x to the 7th. So we want to ask ourselves, what can we multiply 3x squared by to get this stuff? We're going to need a binomial. There's two ways to look at this. One way is to kind of just think about it in your head. 3x squared times something needs to give us that 21x to the ninth. Well, how about 3 times 7? That's going to give us the 21. X squared times x to the 7th. Look at that whole term right there. 3 times 7 is 21. X squared times x to the 7th. We add those exponents to get x to the ninth. So there's the first part of our binomial. Now, 3 times a negative 5. 3 times negative 5 gives us negative 15. X squared times x to the 5th. That's going to be x to the 7th. We just found the binomial that we need. So the answer is 7x to the 7th minus 5x to the 5th. But let me show you a different way of approaching this, just in case that's too hard to follow. So, let me erase all of this. And let's look at it in a different way. Let's divide to solve this. So 3x squared times some junk is going to give us this stuff. If we were to divide both sides of this equation by 3x squared, what we're actually turning this problem into is a division problem. So the 3x squareds would cancel out, and what you have left over here is that mysterious binomial that you're looking for. So we got something that we don't know. This binomial that we're trying to find is going to be equal to this. Now we deal with this problem the same way we dealt with this one right here. We break it up into two pieces. So let's do that. 21x to the ninth over 3x squared minus 15x to the 7th over 3x squared. 21 divided by 3, there's our 7. Subtract your exponents, there's your x to the 7th. So this right here, by dividing and simplifying, you get the 7x to the 7th. And then there's your minus right there. There's our minus there. And then 15 divided by 3 is 5. Subtract your exponents. There's the 5x to the 5th power. So there's that same binomial popping back up. I don't care how you approach it, whether it be the first way I did it or that way right there. But either way, you're going to get 7x to the 7th minus 5x to the 5th. All right, 18, 19, 20, 21, 22, factoring. Factor completely. All right. This first one here, remember the first thing you always want to do is you want to look for GCF whenever you factor any problem. I see a 27, a 9, and a 45. 9 goes into all of those numbers. So let's factor a 9 out first. Oh, what else? Well, we got some A's in all of them. The most that we can pull out, though, is just going to be 1A because that's the least amount that we have occurring in all of them. We can't pull out an a squared from this, so that would be too much. But we can at least pull out 1A. How about our B's? We got 1B here, 2B's there, 2B's there. The most that we can pull out that they have in common is going to be 1B. This is our GCF, and now when we take this stuff out, 9 times 3 is going to give us that 27 back. We need a squared when we multiply this. So a times an extra a is going to give us the a squared. And a b, we don't need to put another b here. All we need is 3a. If you were to multiply 9ab times 3a, do that real quick to check your work. 9 times 3 is 27. A times a is a squared. And then b times no other b is going to give us that b we have right there. All right, bring down your minus. 9 times an understood 1. I'll write it right there right now for the heck of it. So 9 times that negative 1 gives us that negative 9. A, we don't need an extra a since we already have it there, but we do need a b. So how about I just write minus b instead of minus 1b? So take your time right there. Take that, multiply it times this. 9 times an understood negative 1 is negative 9. A times no other a is going to still give us that single a, and then that b times that b is going to give us the b squared. So we get the minus 9ab squared back. And now this last piece here. 9 times 5 is going to give us 45. 9 times 5 gives us the 45. We need an a squared. All we have over here is 1a, so we need an extra a over here. And all we have over here is 1b, so we need an extra b to get the b squared. And notice if we multiply that back out, let me erase what I've done so far. Let's take that and multiply it back out. So 9ab times 5ab. If you distribute that, 9 times 5 is 45. A times a, there's our a squared. That's why I put an extra a there. And then b times b gives us b squared. Now that can be kind of hard to follow, but really what you're doing there is you're factoring out that GCF and you're asking yourself, what do you have to multiply back by to get what you started with? Now you might wonder, what do we do next? Well, there is nothing else that we can do here. We can't do product sum, bottoms up, or any more GCF. So that's our final answer to that problem. Number 19, looking for GCF. There is not one. We have x squared minus 4x minus 5. This is one of those trinomials where you want to find the product and the sum. The product is equal to -5. The sum is equal to -4. Not going to waste too much time here. We've done plenty of these. Two numbers that multiply to give us -5 and add to give us -4 is going to be -5 times 1. That does give you -5. And if you take -5 plus 1, the sum, that does give you -4. So therefore we come back and write our two binomials as x with the -5 and then an x with a +1. That's all we can do there for that problem. Totally factored. So that was a product sum right there. This next problem, number 20, factor it completely. Most of the time when you see four terms, you want to go ahead and jump into factoring by grouping. But before we do that, let's look at all four terms and make sure there's nothing in common between all four of them. We cannot pull a common factor out of all four. However, if we group like this, look at that first group we have. This first group right here, we can pull an a out of those two terms. So if you pull the a out, you're left with 3c. Be careful right here, you're left with +1. Don't just cancel it out and write a 0. Because remember, you want to be able to distribute back and get 3ac, and then that's how we get that plus a back, because a times 1 is a. Let's do the same thing for the second group. They have a b in common, so I'm going to bring the plus down. Pulling that b out, you're left with 3c just right there. And be careful here again, that's going to be +1. Because notice if you were to distribute this b back, that would be 3bc plus the b, because b times 1 is b. Now that we have done that, looking at our two big pieces, we have this piece here and this piece here. They're separated by that plus in the middle. What do they have in common? They have that 3c plus 1 in common. So if we factor that out, and the way I mentioned this in class, if you're factoring it out, just, cross it out and look at what you have left. You have a plus b. All right, and that's it for that one. I'll come back in a second and check all of these. We've already checked that first one we did. Oh, what the heck. Let's just go ahead and check this one and check this one, then we'll finish them off. Checking this real quick, using the FOIL method or however you multiply polynomials, x times x is x squared, x times 1 is +1x, -5 times x is -5x, and -5 times 1 is -5. Combining like terms, we have x squared minus 4x in the middle right there. That's minus 4x minus 5. And notice that does check out with that up there. Checking this one, number 20. Let's do that same technique. 3c times a is going to be 3ac. 3c times b is going to be plus 3bc. I'm just putting my letters in alphabetical order. Then let's do the same thing with the 1. 1 times a is positive a. And then 1 times b is positive b. None of these terms are like terms. So if we look back up here, 3ac, there's our 3ac. 3bc, there that is. And then the a and the b, there's the a, there's the b. It does check out. Now 21, depending on, we didn't jump too deep into something called perfect square trinomials, and I'm not even going to take that approach because you have enough to remember right now, to be quite honest with you. What I would do here, we spent quite some time on what's called bottoms up. There is no GCF to this problem, so the way we can tackle this number in front of the x squared, we move it over to the 16. Yes, that's going to give us a big answer, or a big number, excuse me. It gives us x squared minus 40x. 25 times 16 is 400. Now, remember I said this in class, this is a shortcut to factor this problem, so the product is going to be 400. The sum is going to be negative 40. Now, you might sit there and hunt around for a little while trying to find these two numbers, but 20 times 20 is 400, and 20 plus 20 gives us 40. However, let's make sure we use two negative 20s. Negative 20 times negative 20, that does give us the positive 400. And the reason why I use those two negative 20s is because minus 20 gives us the minus 40. Be careful with those signs. So again here, the process that I'm using is bottoms up. And I'm writing that down, so therefore when we come back and write x minus 20 and x minus 20, we have to remember that this is not the answer to the original problem. How do we get back to that original answer? Whatever number we moved, we come back and divide those two numbers by that number, or by the two numbers that we found here. So we're dividing by 25 because that's the number that we moved up here. And we can simplify both of these fractions. 20 over 25, if you divide by 5 at the top and bottom to simplify that fraction, you get x minus 4/5 for that one. Well, it turns out you get the same thing over here as well. So you have x minus 4/5 for that one. Now, why is this problem called bottoms up? Because if we have a bottom number that is not 1, we move it up in front of the x or whatever variable we're using in the problem. So we move that bottom up, we move that bottom up, and that gives us close to our final answer, 5x minus 4 times 5x minus 4. We did bottoms up on both of them. However, okay, if you left it like that, I'm not going to count it wrong. I'll still give you full credit. But really, what is this equal to? 5x minus 4 squared. That's the final answer. Totally simplified, and it just looks nice. Now, however, let's go back and check real quick. I'm going to check using this one. 5x minus 4 squared is 5x minus 4 times 5x minus 4. Checking that real quick. 5x times 5x, that's going to be, let me do this over here to the side. That's going to be 25x squared. This is just me checking. And then 5x times negative 4, that's minus 20x. Do the same thing with the negative 4 here. Negative 4 times 5 is another minus 20x. And then negative 4 times that negative 4 is plus 16. I know I'm getting a little sloppy, but what we're left with here is 25x squared minus 40x plus 16. Those do not cancel out. They combine together to give you minus 40x. That right there matches exactly what we started with right here. All right. So be careful with bottoms up. Remember, if you have a number that's not 1 in front of that squared term, you move it over, but you have to bring it back in that step right there. So that's our factored form for that one. And then this last factoring problem here, 22, GCF, pull out a 2. Both of those coefficients are even, but we can't pull out any A's or B's, so we're left with A squared minus 100B squared. This is a difference of two perfects, or difference of squares. Now, I did give you the shortcut for this in class. Let's bring the 2 down. That's part of our answer. And then what we can do is we can break these up into 2 equal pairings. A squared is A and A. 100B squared. 2 equal things that we can break this up is 10B and 10B. Notice A times A is A squared. Those are 2 equal pieces that we broke that A squared up into. And 10B times 10B, 10 times 10 is 100, B times B is B squared. So that's 2 equal pieces that we broke that up into as well. And the way to deal with this is a difference of squares, so we can write A plus 10B and then we do a minus 10b. The hint that I gave you in class 2 is if you have two terms when you're starting off, we have two terms. Once we pull the GCF out, not every time you factor, but that's something you want to look for, is a difference of squares when you have two terms. If had that been an addition symbol there would be nothing else to do, but this is a difference. That's what that difference means right there, a difference of two squares. And that is it for that problem. On to 23. The area of a rectangle is 25x squared minus 40x plus 16 square feet. Find the dimensions of a rectangle. Now I want to back up to two problems. All right, what we're doing, one problem that we did earlier, right here, we were given the dimensions of the rectangle and we had to go and find the area. So I'm going to go off on a little tangent real quick, back on this problem before I go and complete the other one. Suppose we have 8x squared minus 22x plus 15. And that was the area. What we're doing to get back to these two pieces is we're going to factor. So this is a good time to practice another factoring problem. I'm going to show you how we go right back to those problems. Let's move the 8 over to the 15. This is a bottoms up. So therefore we have x squared minus 22x and 15 times 8. It's too early in the morning. 120. So plus 120. All right. Now, what we want to do, we want to find two numbers that multiply to give us 120, and the sum is going to be negative 22. I'll tell you those two numbers real quick. If you multiply negative 10 times negative 12, that gives you positive 120. And if you take negative 10 plus a negative 12, you get the negative 22. Now watch. What I'm going to do in the end, we're going to end up with these two factors. It's because we're factoring. We're going backwards from the multiplying that we did earlier here. So continuing bottoms up, we have x minus 10 and an x minus 12. But remember, you want to bring back that number that you moved. So let's bring back the 8 here and bring back the 8 here. Dividing these by 2 to simplify that fraction, we get x minus 5/4. Dividing these two by 4, we get x minus 3/2. And now to finish this bottoms up, we move the bottom piece up if it's not 1, because we didn't get a whole number here. That is a fraction. So therefore we have 4x minus 5, moving that bottom piece up, and then move that bottom piece up there. We have 2x minus 3. Notice those two pieces, and like I said, if we took that answer we got way back a long time ago in the video, if we were to factor that back out, look at those two pieces that we get, 4x minus 5 and the 2x minus 3. And that's exactly how we solve number 15. So that was a little tangent I went off on, but hey, we got to practice another factoring problem as well. Now the next problem I want to look at, 21. The reason why I want to look at that one again, we've already got that answer. It was what? 4x minus 4 squared. See that right down there? All right, those two pieces. Why am I copying that over? Well, that is the exact same thing. Look at that. Problem 21 that we've already factored. 25x squared minus 40x plus 16. Bam. So actually it turns out this thing is not a rectangle, because 5x minus 4 squared, remember, we just checked this one a while ago, that's the same thing as 5x minus 4 times 5x minus 4. To give this a more precise name, this is actually a square, because those are your two dimensions, and since those two things are the same binomial, it turns out this rectangle is actually a square. So therefore the dimensions will be 5x minus 4 and feet, so let's not forget that, 5x minus 4 feet by 5x minus 4 feet. Now, if you didn't pick up the idea that these two were the same and you didn't say, hey, it's a square, it's okay. The dimensions are 5x minus 4 feet by 5x minus 4 feet. So that's what we want to do for that one. All right. 24 x squared minus 8x equals negative 12. We got to solve this equation. To solve a quadratic equation, one of the main techniques I shared with you is you want to force a zero. By forcing a zero, that means you want to get 0 on one side. So I'm going to add that 12. Therefore, we have x squared minus 8x plus 12. This is now equal to what? We have forced a 0. Negative 12 plus 12. I know that cancels out, but I'm going to show that 0 over there. One of the most common ways to solve a quadratic, there's several techniques. The one that I'm going to do here, hey, this thing probably factors. The product is going to be 12. The sum is going to be negative 8. If you take a negative 6 times a negative 2, that gives you the positive 12. And if you take negative 6 plus a negative 2, that gives you the negative 8. This is not a bottoms-up problem because we have that 1, understood 1 in front of x squared, so we can go straight to our factors. X minus 6, x minus 2, based on the two numbers that we found up here, and this is still equal to 0. And from here, let's set each one of these factors equal to 0 to solve this. So x minus 6 equals 0. Solving that equation, you get x equals 6. There's one of our answers. And the other answer set this factor equal to 0. Therefore, we get x is equal to 2. So we get two answers here, a positive 6 and a positive 2. Let's go back and check that real quick using a little bit of mental math. So the original problem was x squared minus 8x is equal to negative 12. One of our answers was 6. If we plug in 6, let's do this real quick. 6 squared is 36 minus 8 times 6 is 48. I'm just plugging in 6 into both of these x's. 36 minus 48 does equal negative 12. So what I did there is I plugged in 6. It worked out. Let's do the same thing for 2. Now notice what I did not do. I did not plug in 6 into one of the x's and 2 into the other x. You want to plug in 6 into every x. That's what we did up here. Now let's do the same thing for 2. So 2 squared gives us 4 minus 8 times 2 is 16. 4 minus 16, that does equal negative 12 as well. So those are our two answers to that quadratic equation. And finally, the last one, another quadratic equation. And what we have here, it says a window washer accidentally drops a bucket from the top of a 144-foot building. The height h of the bucket after t seconds is given by h equals negative 16t squared plus 144. When will the bucket hit the ground? Now I'm going to take a different approach to solve this one. Since we have two terms and there's only one type of t floating around, it's just a t squared. Notice there's not just a plain old t floating around. The height of the bucket, h represents the height of the bucket. T represents how many seconds after the guy dropped it. So when will the bucket hit the ground? Well, the question you want to ask yourself, when the bucket hits the ground, the height is going to be 0. The height. So we're plugging in 0 for h because that's when the bucket hits the ground. And we're trying to figure out when. How long is it going to take? Well, we got to solve for t then. So we have negative 16t squared plus 144. But watch how I'm going to take this problem and solve it. I'm going to subtract the 144 from both sides. I'm not worried about forcing 0 here. I'm going to take a different approach to this. 0 minus 144 is negative 144. This is equal to negative 16t squared. We can get the t squared by itself by moving the negative 16 over here. To do that, we divide. And then if you take negative 144 divided by negative 16, you get a positive 9 if you divide those. Over here, the negative 16s cancel out, so you get t squared. And now we can get that t by itself by taking the square root of both sides. So therefore, the square root of t squared, the square root of 9 can be plus or minus 3, and that's equal to t, but the one we want is going to be the positive, because think about the real-world application here. We're trying to find the amount of time. We don't want to use negative 3 seconds. We want to use the positive 3 seconds. So therefore, we can say it will take 3 seconds for the bucket to hit the ground. Make sure, real world application, make sure you do give a little quick sentence when you're solving that problem. Again, we didn't want to use the -3 because of the fact we're talking about time, and let's not talk about negative time. It blows my mind. But there you go, 25 problems. If you can do these 25 problems, or hey, if you can do most of these 25 problems, I assure you, you'll see some things very similar on your DMA 60 mod exam. I recommend looking at this once, twice, whatever. Don't wait until the last minute to ask me questions. You know, we're going to have some review days. So that would be perfect for you to, you know, look at this video maybe at home, come into the review days in class, and I can maybe answer some questions that you still may have about these problems that we worked out. But that is it for this video. Hope it helped.